Hi there, everyone. This is a continuation of solubility and ionic equations. So if you take a look at the last lecture that I have posted on YouTube, this material, we sort of walked through it. We talked about how to utilize the solubility chart, and in the previous example, the entire equation was filled out for you. So in this case, you are going to fill out the potential products and whether they would be solid or aqueous. All right? So I have the page up here, the solubility chart. Now I would suggest that you have the solubility chart with you as you're working whatever your textbook utilizes. So here is the solubility and ionic equations chart. And if you come and you take a look down here, this is the reaction that I'm proposing. So we're going to take potassium phosphate, which is aqueous, and we are going to mix it with calcium nitrate, which would also be aqueous. So the question is, will a precipitate form? If so, what would it be? And what are the potential products here? So you're going to create your molecular equation and balance it. That's the first step. Now the step after that's going to be to create a complete ionic equation. For the complete ionic equation, this is where all of the aqueous portionalities break apart into their formal ions. This needs to be balanced so that all the spectator ions can cancel out. And then finally, you're going to use a net ionic equation if one exists in this case, because if they're all aqueous, then they're all spectators. But if there is a precipitate, what would be the net ionic equation? And that is the last portion of what you are going to work on here. So you can see the initial equation here that I've brought up. So your first job is to predict the products that would come out of this reaction along with their various states and to balance the equation. All right? So pause the video at this point, attempt to do that, and then you can come back for the walkthrough as you are proceeding along. All right? Now I'm going to go ahead and I'm going to get started with this walkthrough so that people that are ready can continue on here. All right, so if I take a look at this, I have potassium phosphate and calcium nitrate. So I want to mix the cations with the new anions that they're not currently mixed with. So one of the first things would mean that I'm going to mix potassium with nitrate. Now potassium nitrate, I think about potassium. Potassium is K+, and nitrate is NO3-. So if I bring these together, I only need one of each, and I would expect that I get KNO3. So that would be the compound. Remember that the polyatomics, the nitrates or the phosphates, they come together as a whole unit. Okay? Now, when I take a look at this, I go up and I find that nitrate is going to be soluble. There are no exceptions on the solubility table here. So I would classify this as an aqueous compound. Okay? And then the other thing I need to create here is calcium phosphate. Now for calcium phosphate, calcium would have a 2+ charge, and phosphate, PO4, is going to have a 3- charge. So the common multiple here, the common factor would be 6. You could also crisscross the charges, and that would work in this case. So in other words, I'm going to need 3 calcium to get a 6+ there. So it's going to be calcium 3, right? And then the phosphate, I'm going to need 2 of those in order to get 6-. So the way we do that is we put it in parentheses. We're going to have PO4. I would like 2 of these. And now the question is, what would the state of the calcium phosphate be? Would it be solid as a precipitate, or would it be aqueous? So I can come up here and I can take a look. Here's phosphate. Phosphate is normally found in the insoluble section. It does have a few exceptions. The exceptions are ammonia and the alkali metal cation. So is calcium an alkali metal? No, it's an alkaline earth metal. It's in row 2. It's not in row 1 like lithium, sodium, potassium, and all of those. So I would expect that this is primarily going to be solid. It's going to be a precipitate. So I will have a net ionic equation when I get through with this. Right? Now the next step, the most important step as you get ready to break apart the rest of these equations, is I need to balance my molecular ionic equation. That's the final step as I'm getting ready here to move on. So in order to prepare for that, I'm going to go ahead and I'm going to start balancing. I would say I have 3 potassium over here, and I have only 1 potassium over here. So let's go ahead and put a 3 in front of the potassium nitrate for right now. Okay? So then I look at my phosphates. I have 1 phosphate over here, but I have 2 phosphates over here. Right? So in that case, I'm going to need a 2 in front of the potassium. I then go to calcium. Now, some people may be tempted. The way I normally teach balancing equations, once you've balanced one, go through everything before you go back and attempt to rebalance, okay? Because the potassium just got screwed up here. So some of you may already be seeing that in your head. So how many calciums do I have here? Well, I've got 1 on the reactant side. I've got 3 on the product side. So I'm going to go ahead and I'm going to put a 3 in this portion here. And then I continue forward. How many nitrates do I have? I have 2 of them here. And I have, I'm sorry, I don't have 2 of them. I've got 2 here, but times 3 is 6, right? And over here, I only have 3 of them. So this is going to need to be changed to a 6 in order to make that work. Okay, so now I can go back through and I can look at all of these and see if they balance. So potassium, I have 6 on the left here. And now, this is why we wait until the end, I have 6 on the right. So everything's fine with potassium. Phosphates, I have 2 phosphates on the left. I have 2 phosphates on the right here. And then if I look at calcium, I've got 3 calcium, 3 calcium. And the nitrates, that's what we just finished with, I have 6 and 6. So now this is balanced. Let's go ahead and clean it up just a little bit because I scratched that out there. So we'll put the 6 there in front of it, right? And then we'll move forward with our net, I'm sorry, not our net, our complete ionic, and then we'll get to net ionic. So remember, when you deal with your complete ionic equation, anything that would be aqueous is going to break apart into ions. So potassium, we said that I have 6 of them here. So I have 6 potassium plus. Keep in mind, again, that students oftentimes will put a number down here. That is not going to be present there unless it's one of the polyatomics. What we have is a total of 6 potassiums, and those potassiums have a charge of 1 plus apiece. All right. Then the phosphate. I have 2 phosphates, so I would say I have 2 phosphates, and they have a charge of 3 minus. All of these would be aqueous if they originated from an aqueous source. Okay. And then additionally, I have 3 calcium. So I would say I've got 3 Ca2 plus, again aqueous. And then I also have 6 nitrates, right, when we were balancing this. So 6 NO3 minus. Now some students get confused where this came from. Here's the nitrate, the NO3. I've got 2 of them per molecule, and I'm asking for 3 of these molecules. So if I count that up, that's going to be a total of 6, all right? So this would be aqueous, and that takes care of the reactant side. So now moving over to products, the potassium nitrate is aqueous. So I would go ahead and I break it apart. I have 6 potassium that are aqueous. All right. I also have 6 nitrates that are aqueous. And then finally, the last thing, which I'm putting down here just for the sake of space on the board here, is that I am going to have the calcium phosphate, and that is solid. So that's going to stay as a solid because it would not break up in solution into the various ions. Okay, so PO4, 2, solid. Now remember, at this point, the spectator ions are going to end up canceling out. So we'll go ahead and move these out of the way here. All right, so I no longer need the potassiums. They're not participating in the reaction. Right? I no longer need the nitrates. They're not participating in the reaction. So I'm bringing calcium and phosphate together in order to create calcium phosphate solid, the precipitate. That's the reaction occurring here. This is a precipitate reaction. All right, so what we just showed at the portion below the molecular equation there, that's the complete ionic. All right, so right here, this is the molecular ionic equation. This is the complete ionic equation, and this is the net ionic equation that we're coming to next. Okay, so the net is only what actually reacted, the net reaction. So if I take a look at that, I would say calcium, I've got 3 calcium, 2 plus aqueous, and I added that to 2 phosphates, 3 minus aqueous. And what did this yield? This yielded the precipitate calcium phosphate. Wait a minute, I'm screwing this up here. 4, 2, solid. All right, and this would be the net ionic equation. Notice that this is already balanced. Everything that we needed should be balanced after we do the initial balancing. It all just trickles down through the rest of the equations here. And this is the net ionic equation for the formation of calcium phosphate. So hopefully everybody found this useful. Again, I know this was a little more difficult than the last video simply because I was asking you to figure out the initial reaction by yourself, where in the previous video I just gave it to you. But you want to get used to using that solubility table in order to solve for this, okay? So thank you so much for learning with us. If you leave any comments, I'll try to get back to you as soon as possible. If you want up-to-date videos, you can always subscribe, and by hitting the like button, it helps the channel in terms of its growth, and we can continue to put out content almost daily for you guys. So thank you so much for spending the time to learn with us, and we'll see you guys next time.